So here's a function, two variable function, and u hat is, okay, this hat means what? Unit vector. So it's a unit vector that points to the fastest increasing direction at -2, 1. Oh wait, I heard this from somewhere. What does this have anything to do with? The gradient. See, gradient always points to the fastest increasing direction, right? But I guess the difference is that the gradient doesn't have to be a unit vector. In fact, the norm of the gradient tells you the highest value of the directional derivative. So it's usually not a unit vector, whereas this is a unit vector. So that suggests the idea for finding u hat is to find the gradient first and normalize it. That should be how you do A. And then B, it's asking you to calculate the directional derivative, and of course the formula is gradient of f dotted with u hat. So we're going to be using this for the part B. Okay. So let's try this one by one. For part A, gradient is calculated by taking the derivative with respect to x as a partial derivative. That means I'm keeping y as a constant. So x cubed gives you 3x squared. X differentiates to 1, so it's minus 3y. And then y squared differentiates to 0 because y is a constant. So this is the partial derivative of this function with respect to x. Now for the second part, I have to differentiate this by y. If you differentiate this by y, x cubed differentiates to?
3x squared.
No, I just said differentiate by y. If it's a partial derivative with this, yeah, it's 0, right? And then if I do the y, differentiate by y?
Negative 3x.
Negative 3x.
Oh, we get that.
And then if you differentiate this by y?
2y.
Okay. All right, this is not yet the gradient because we want the gradient at -2, 1. So let's find the gradient at -2, 1. And that's going to give me -2 squared is 4, so that's going to be 3 times 4 minus 3 times 1, -3 times -2 plus 2 times 1, which is 12 minus 3, that's 9. Positive 6 plus 2, that's 8. Okay, so the vector is 9, 8. Now we have to, this is not yet the u hat. To get the u hat, you need to normalize this, which means now I have to find the norm of it. Square root of 9 squared plus 8 squared, which is 81 plus 64, and that gives you 145. Okay. So you get 145. And therefore, the answer to part A is u hat is equal to 9, 8, and you divide it by square root of 145. So that's the answer to the first one. Okay, and then the second one is directional derivative of f at -2, 1 is gradient of f at -2, 1 dotted with u hat. And we know that this one is over there, 9, 8. Dotted with 9, 8 over square root of 145. Dot product means component-wise multiplication. Any scalar, you can bring it outside. So we're just doing this dotted with that. So 9 times 9 is 81. 8 times 8 is 64. That also gives you 145. And when you divide by square root of 145, I mean, you shouldn't leave it like this because you need to rationalize the denominator. But if you rationalize the denominator by multiplying by square root of 145 top and bottom, you see that this thing just becomes same as that one. leaving you with 145 square root. So that's the answer to part B. Now, a shorter alternate way to get this answer is to say, well, you are trying to find the directional derivative of the maximum, the directional derivative of f in the gradient direction. In that case, that's the maximum possible value of the directional derivative, right? And we learned that in that case, simply the norm, this is going to be same as norm of f. But norm of f, we already computed that, that's square root of 145. So if you knew that the gradient norm of the gradient holds the information about the maximum value of this, then you can just go there without having to go through all that trouble. Yeah. Did that last comment make sense? So last time I spoke about gradient. So what are the three important properties of gradients? First is perpendicular to level curves, okay, or in 3D level surfaces, right? Second, it points to the fastest increasing direction. And then those two tell you the direction of the gradient. That determines the direction of the gradient. But the third one tells you what's the meaning of the norm of the gradient. The size of this gradient vector is the maximum possible value of this directional derivative, right? And that's why in this case it is the norm of gradient f itself. Okay, so if you knew that, you didn't have to go through all that and just find the answer as that. Yes.
So, do you mind repeating the properties?
Yeah. So perpendicular to level curves.
Yep.
It's pointing to the fastest increasing direction.
Yep.
And then third, the norm of the gradient of f is the maximum possible value of the directional derivative.
All right, thank you.
Yeah. And in here, this does pick up the maximum possible value of the directional derivative because this is the fastest increasing direction. So this will be the maximum value, which is this one. We also find it that way as well. All good?
Yes.